Hey everyone, thanks for sticking around. Here we go. We're going to check out a 2D projectile motion problem, and so let's just start out by reading it. So a cannon fires at an angle of 30.0 degrees above the horizontal with an initial velocity of 50 meters per second at a castle that is 200 meters away. If the castle walls are 10 meters tall, will the cannonball make it inside the walls? So essentially, are the people safe, or should they be watching the heck out, right? And so I'm looking through and I see we have a few things. We know our angle, we know our initial velocity, and that's not the x velocity, it's not the y, that's the total. We know the x direction for how far away the castle is, and we know the height that we need to be. This is kind of the y value. And so the question is really, will the cannonball make it inside? And so you don't need to have our kind of notes here from last time at the end of the notes. I just have these kind of here as a courtesy, so you can kind of follow along, and hopefully this kind of helps out. I would challenge you, if you feel comfortable, try work ahead of me a little bit, and if not, don't worry about it. So step one, draw a picture of what the heck's happening. And so here we go. I'm just gonna have like a little castle, and it'll just be kind of little janky castle wall. Nothing special. This is an AP art, luckily, just AP physics. So there we go. There's our castle wall. And here is our cannon. And it's just going to fire this cannonball. Womp. There it is. So there's our cannonball. And we're told that we know the angle. Actually, I'm going to redraw my cannon a little steeper. Something like that. Just because it'll be easier for me to show that, hey, look, our angle here, this is 30.0 degrees. Terrific. And we're told that the initial velocity is, so we'll say V naught. That's our 50.0 meters per second. We're not going to be too finicky about sig figs here, just a heads up. And the whole goal, and this is obviously not to scale, right? Obviously not to scale. We could go ahead and shrink it if we want to be kind of like that. You don't have to shrink it though. You probably can't shrink it. And so here we go. We need to be over this height that is 10.0 meters tall if we want to wreak havoc and devastation on the poor villagers inside our castle. And we know that from the cannon to the castle, it is 200 meters. So again, really, we're just doing step one. It just says draw a picture of what's happening. I've drawn a picture. I've just shown what we know. That's really all there is to it. Step two, draw a triangle for the object's motion and do sine and cosine. Okay, so here we go. We'll just have our triangle like this. A little bit of a bigger triangle will make it just a little easier, in all honesty. And then I will have red as my x. So there's Vx. This is our initial velocity. And I will have blue for my initial y velocity. And we know that our angle, you could use green for this, we know that our angle is 30.0 degrees. Terrific. And we know the initial velocity is at 50.0 meters per second. So it says use sine and cosine. So let's just do that. So sine of our angle, and you might need to look back at our notes, sine is opposite over hypotenuse. So sine would actually give us then the initial y velocity divided by our initial velocity itself. So I'm just going to put V naught here just to kind of start us off. And so plugging that in, I would have then sine of 30.0. Make sure your calculator is in degrees, not radians. We may mess with radians one day in a few units. Is our initial y over our 50.0 meters per second. So really all I need to do here to get my initial y velocity is I need to multiply by 50 on both sides. So taking out my calculator, 50 if I times by 50 meters per second on both sides. It'll cancel over here, and I need to multiply by the left side as well. So 50 times sine of 30 gives me 25, and we could keep sig figs, 25.0 meters per second is our initial y velocity. Now, something I like to do is I like to circle some things that I'll end up using later if I end up writing a lot and I get kind of confused. You don't have to do it, but I'll do this just so it's kind of handy. It'll pop out and be a little easier to find. So we've drawn the triangle, we've done sine. Now let's just do cosine. So cosine of our angle, well, that'll end up giving us our x velocity over our hypotenuse, which is just the initial kind of total velocity. And so plugging in again, cosine of 30.0 gives us our x velocity over, our 50, and that's meters per second. So now I'm just really going to have to do 50.0 times cosine of 30.0, and that gives us a value of 43.3 meters per second is our x velocity. Now again, since we ignore air resistance, this is constant. This value isn't changing. If you were taking into account air resistance, yeah, it'd be getting slower and slower, but we luckily don't have to do that. So we've done step 1, we've done step 2, we've done sine, we've done cosine. Now we got to make that T chart. So I have some space here, so I'm going to say that this is my horizontal side. This will be my vertical side. I'll kind of split it a little longer down the middle this time. You can always add a little more. And I'm just going to put the same couple things that we had last time, really. And so we had that our x velocity, I'm just color coding so that it kind of stays the same here, is x over time. And also that cosine of our angle is going to end up being the x velocity over the initial velocity. And that's really it. That's really kind of all we know so far. But we also do, in fact, and let's kind of add a couple things here. We know actually that our x velocity, since we did step 2, we already know what the x velocity is. So I'm just going to put that over here. This is already kind of a lot to keep in mind at once. So it's kind of nice just having it down here. We can figure that out. Now, let's look at the vertical. The vertical, we kind of have all these crazy equations that we had from our equation sheet. And so we have that our y velocity is the initial y plus acceleration in y times time. We have that the y final is the initial plus the initial y times time plus 1/2 the y acceleration times the time squared. Don't forget that squared. And then we have the final velocity is the initial squared plus twice the acceleration in y times the difference from where it starts and ends. Plus this sine stuff too, right? So we now have sine of our angle is our initial y velocity over the initial. But we also know what the heck that initial y is, and that's going to be really crucial here for us. And then we're going to actually get to look at and see how the heck do we even do the problem, because all we've been doing kind of is blindly following the steps here. So we've made the T chart for the vertical and horizontal components. Excellent. So really, at this point, if you can do sine and cosine and you can draw a picture, you can do this for every single question we have. We can draw the picture, we can make a triangle, we can do sine and cosine, and we can just blindly plug in the equations from the equation sheet. That's really kind of all we've done so far. So now, what the heck do we need to do? Step 4 is where it's actually do some hard thinking. So what the heck's going on here? So will the cannonball make it inside the walls? So here's kind of the idea. And it's that as the cannonball kind of goes along this parabolic trajectory, is its y value when it's at 200 meters, so when it's at this x position, is it below 10 meters Or is it above 10 meters? Because if we can find out the y value when it's at 200 in the x, we'll know if it makes it inside or not. And so really, looking at this, we're going, what the heck is our master equation? Well, I want to look at our verticals here, because really the goal is, if we need to find out if it's going to make it over the walls, we need to find what the heck the y value is. Where is it along here? Is it up here? Is it up here? Is it down here? Where is it in the y direction is really what it's asking about. So my master equation is going to be something that has a y value in it. So already I can look at this and go, that one's out. There's no y in it. I'm looking at this one, and I'm looking at this one. One of these two is probably going to be the correct thing. And so I don't know exactly which one yet. We know that gravity is the acceleration here, and we know the initial y velocity actually. This thing is, we could make that blue, so we actually know that that's actually the thing that we already know. So we know that, but we don't know what the final y velocity is when it's like at this position. If we knew that, we could plug into this guy. Now, looking at this second one, we know that, or we always get to kind of call wherever it starts 0. So we're going to say it starts on the ground, so that's 0. We do, in fact, again know this initial y velocity. We know gravity is the acceleration. Gravity is that negative 9.8 meters per second squared. We'll end up kind of plugging that in soon. But we don't know the time. And so we kind of have these two equations, and both of them have two unknowns. We want to get y, but we either need to find the time to use this equation, or we need to find the y velocity when it's right here. So here's where the horizontal part is going to help us out, because we know the x velocity and we know how far it's going. It's going to be going 200 meters in the x direction. So right now, we're going to plug into this and we'll find the time. And then that time is going to get plugged in here and here. And then we can use that to find the y value. And if the y value, when it's at the time to get right in this kind of 200 meter away in the x direction, if that y value is greater than 10, we say yes, it makes it inside the walls. If it's less than 10, we say no. So let's go ahead. We've done kind of the hard thinking part. I'm going to go ahead and actually do like a little circle around this guy. This is our master equation. We figured it out. So we've done step 4. Step 4 is the hard thinking part. And now step 5 is find all those values. So let's go ahead. Let's solve this guy right down here. So we have our 43.3 meters per second is equal to 200.0 meters over the time. So do a little algebra. I'm going to multiply by time on both sides, and then I'm going to divide by 43.3 on both sides. So really, I'm just kind of switching these two is what's really going to happen. So we have time is now 200.0 meters over 43.3 meters per second, and that checks out because I look here and I go, hold up, meters and meters cancel, 1 over seconds. We're going to get seconds for our units. That's perfect. So 200 divided by 43.3 gives us right at, and we're following sig figs, so our time is going to be 4.62 seconds. So now we have the time. We're going to plug it into our master equation with everything else that we know. And so the y value at 4.62 seconds, because that's when the cannonball is 200 meters out in the x direction, it is our initial y velocity, so 25.0 meters per second, times this time, which is 4.62 seconds, plus 1/2 gravity. Gravity is in the negative direction though, so negative 9.8 meters per second squared, times our 4.62 2 seconds, and we have to square that time. Now, I do this all in the calculator in one step. I literally enter it in exactly as you see it. So I'm going to just go ahead in one step. You could be that person. You can multiply these two and you have a new term and do all this stuff and then have a new term and then combine them. But you're going to put in more room for like weird rounding mistakes to happen. So I just do 25.0 times 4.62 plus 0.5 times negative 9.8 times 4.62 squared, and this gives me a y value of 10.9. Okay, now looking at our sig figs again, maybe you go, all right, 10.9, I'm going to leave it at that. Or you could look and say, well, we're multiplying here. These two numbers that are actual measurements, this one has 2 sig figs, and so this would round to whatever it is, and the answer would actually have 2 sig figs, and it would only have 1 decimal place then, really. And then if we're adding it here, the decimal place rules, so then that would only have 1 decimal place, and so in the end, we could leave it at 10.9. Maybe you went and you called it 11. Either way, we've gone ahead, we found all the variables, and we used the master equation. And so really, we're kind of done. We know the height now. So with our question here, will it make it inside the walls? Absolutely. This cannonball is going to be like right here, flying in just over the wall. Maybe it's going to take someone out who's standing here on the walls even. So really, the short answer is yes. It will make it over. Yes, it will make it over. Watch out. So I hope that made sense. Really, we did just follow these exact same steps. I will say step 4 is where it gets tricky and you have to do that hard thinking part. So hopefully let me know what questions you have, do a little review, and I'll see you next class. Thanks for sticking around.